Hello and welcome to part two of algebraic expressions. We'll be going over indices and we'll also be covering surds, how to simplify and rationalize them. Let's get straight in to the video. So let's have a look at part E and then we'll also explain how we use these laws. I will cover these as we go throughout, so just make a mental note or take a screenshot of them. So for part E, what I'd like to do is I like to split it up into its components. So we're going to write 3 in the cube root of 125, and this is going to be multiplied by the cube root of x to the power 6. Now I can essentially write this as 125 to the power 1 over 3. Later on, this will become very useful and you'll understand why. And this is going to be multiplied by x to the power 6 to the power a third. And as you can see, you can multiply the powers with the 6 and the third, so it becomes a lot easier to deal with. So it's going to simply be 5x squared, and there's our answer. Let's move on to part F. We're just going to switch to a different color. Here, now remember what we said about last time. We cannot do any cross multiplication, so we have to separate it into its different components. I'm going to write 2x to the power 5 over minus x to the 5. Okay, and when I simply solve this, I will get 2x to the minus 3, because 2 minus 5 is minus 3, and this is going to be minus x to the minus 4. Now remember, this can be written, it's not compulsory, it can be written as 2 over x cubed minus 1 over x to the 4th. It's exactly the same thing. Okay, let's move on. We're going to have a look at this question over here, part B. So to solve this question, all I am doing is the cube root of 64, and you can type that into your calculator straight away. Now, remember, it will be 4 in this case because 4 times 4 times 4 is 64. So the cube root of 64 is just 4. If it was asking for the square root of 16, so we normally just write square root 16 like this, that would also equal to 4. Okay, so the cube root of 64 is equal to 4. Let's have a look at a little bit more complicated examples. So here we have 49 to the power 3 over 2. What we're going to do here is a very similar approach. What I like to do is do the square root, because I know that this is essentially 49 to the power 3 times a half. So I'm going to do the half first. So remember what this would be? 49 to the power a half. It can be expressed in this form. Yeah, so 49 to the power half is going to be 7. And then when I do 7 cubed, it's going to be a lot easier for me to show my work. Obviously, remember, you would be allowed to use a calculator if you're not happy, but this does show you the general steps. And I know you can use a calculator to do this, but when there is algebra involved, when there are just x squares, it becomes a lot easier to manipulate if you know how to do this. So please bear this in mind. Don't do it the easy way for now. So you're simply going to do 7 cubed, which I believe is 243. Yeah. Let's move on to this next question. So here it says 25. I'm going to do the same logic. I'm going to do to the power a half, and then I'm going to cube all of that. But this time it's the minus a half, right? All minus does it is it flips it, so it becomes the reciprocal, which means we're actually going to be dealing with 1 over 25 to the power half, and all of that will be cubed. So this is simply going to be 1 over 5 cubed, which is equal to 1 over 125. And that is going to be our final answer. Let's just move this on here. I've realized that you guys couldn't see what was going on, but that's how we're going to get our final answer. Okay, let's move on to this next question. Now, this is a little bit of a challenging question. What I want you to do is pause the video and have a go at solving it by yourself. Okay, so let's, hopefully you've had a chance to go through this video. Let's actually try and solve it together. So for this first one, let's start off with part A. All I'm going to do is I'm going to sub in 1 over 16, I'm going to write the x squared. I could write it on the top, but I'm just going to leave it as it is. And this is to the power half. That's all we want. So essentially, we're just square rooting everything. So if I treat this separately, I'm going to do square root of 1 over 16 and the square root of x squared. So this is going to give me 1 over 4x. And there's my answer, x over 4. Okay, let's have a go at part B. We'll do this in a different color to avoid any confusion. So this time we've got 4y to the minus 1. So I'm just going to sub this in. 1 over 16 x squared to the power minus 1. And because it's to the power minus 1, I'm flipping it. That's all I'm doing. So let's separate it. So this is going to be 16, and then 1 over x squared. That's it. So now we're just going to get 64 over x squared, or 64x to the minus 2. And there's our answer. Okay, now we've written it in a form where it's in kx to the power n. Okay, let's move on to the next style of questions. So with part A, we just need to simplify root 12. Now, I know that root 12 is essentially root 3 times root 4, and root 4 is the same as 2. So we've got root 3 multiplied by 2, which is the same as 2 root 3. Hopefully this makes sense. All we're doing over here is simplifying our surds. So we're taking out the biggest multiplier. So with root 20, I know that this is essentially composed of root 4 and 5. And I know that this will essentially just be root 5 as of root 4, and the 2 will cancel each other out. If we move on to part C, so all we're going to do over here is write it as 5 root 6 minus 2 root 6 root 4, and then we're also going to add our root 6 times root 49. What we've done over here is we've realized there's a root 6 appearing in each of them. So we can take that out as a common factor, and then we're factorizing it. So it's going to be 5 minus 2 root 4 plus root 49. And if I solve this further, I'm going to get 5 minus essentially 4, because it's 2 times root 4, which is 4, plus 7. And this is all multiplied by root 6. And at the end, we're going to get root 6 multiplied by 8. So there's my answer, 8 root 6. Hopefully you're happy with that. If you're not, please pause it and go back over it one more time, just so you can follow it through. All we did was we took out the common factors. Okay, and finally, the last step for this video is rationalizing. So if we have something in this first form, all we're going to do is multiply the top and the bottom by the denominator. So this means that we'll end up with root 3 over 3. For something like part B, all we're going to do is multiply by the conjugate. What that means is if there's a plus sign here, you're going to multiply by that by 3 minus root 2 and 3 minus root 2. Remember the difference of squares over here. So for this question, we're going to end up with 3 minus root 2 on the top, and then it's just going to be 9 minus 2. Okay, we're just doing 3 times 3 minus 2. This only works in this conjugate form over here on the bottom, just because of the difference of squares rule. If you were to do the FOIL method, you would see why that works. If you're not familiar with FOIL, please go back and watch my last video where I cover it in depth. Okay, and then the final question for this, no matter what's at the top, you're still going to multiply by conjugate. So here we're going to multiply by root 5 plus 2 and root 5 plus 2. We're always trying to get rid of the surd on the bottom. That is the aim of these type of questions. So we've got root 5 plus root 2 whole squared, and I am doing root 5 minus root 2 multiplied by root 5 plus root 2. So remember, we can use difference of squares on the bottom, so it's nice and easy. So it's just going to be 3, because 5 minus 2 is 3. The reason why that works is just be careful and watch out for the square roots. And on the top, we can use our a squared plus 2ab plus b squared formula. So that's simply going to be 5 plus 2 root 10 plus 4 which means that our overall answer is going to be 9 plus 2 root 10 over 3. And there you have it. Thank you for your time. Thank you for watching. Please drop a like and subscribe, as I will be uploading every day. Thank you.